Water, soil, and air are the three most precious resources of the earth. Without soil, the very survival of mankind and the larger ecosystem is not possible. Indeed, it is difficult to fully appreciate the importance of soil to life. Since ancient times, mankind has been deeply aware that the soil is the source of all living things. The soil provides food and building materials, regulates the environment, enables the operation of the ecosystem, and preserves human culture. It gratifies the most basic human needs: the needs for substance, clothing, shelter, transportation, and happiness. It is a precious resource vital to human life. With the exception of solar energy and carbon dioxide, soil provides plants with everything they need to grow, including nutrients, water, and oxygen. Soil is one of the best media for plant growth. It anchors the roots of plants and allows them to absorb the water and nutrients needed to support life. Soil provides 15 nutrients and minerals needed to support plant growth. It also provides most of the elements necessary for human life. The stability of human life depends on the ample availability of food, and soil is the basis of all food production. A Chinese proverb observes that food is the principal need of the people, and the earth is the source of food. From time immemorial, wars have been fought around the world to control and defend land. The downfall of many of the world's ancient civilizations was closely related to the decline of their agricultural productivity. The soil provides grain, vegetables, fruits, beverages, medicinal materials, and spices for human consumption. It is the source of feed and grass needed for raising animals, in turn a source of protein. The soil also produces the cotton for clothes and the lumber to build homes, meeting the basic human needs of clothing and shelter. Throughout history, wood has been an important source of fuel. The global oil crisis has intensified the quest for alternatives to petroleum-based fuels. Plants are one such alternative. They can be synthesized into various types of energy matter that can be used as a source of fuel. For example, sugarcane and cassava are ideal sources of fuel alcohol. With the help of soil, mankind is able to produce plants that enrich our life. While plant factories and hydroponic farming seem to hold much promise as an alternative to soil in the cultivation of high-quality produce, the required technology, capital, and cost of such methods must be considered. By comparison, soil is a low-cost cultivation medium. Soil stores water, fertilizers, and nutrients to facilitate farming. With the help of science and soil surveys, farmers today are learning how to precisely use and manage this important resource. Although soil accounts for only the thin surface layer of the world, this layer is where the great drama of life largely unfolds. Within almost any handful of soil, one will discover a variety of organisms, both visible and hidden to the naked eye. This amazing diversity of organisms is what provides the rich vitality and ever-changing quality of soil. Microorganisms live in the 5% or so of the space of soil occupied by organic matter. These organisms undergo complex interactions in the soil. Soil colloids and humic molecules absorb important biological molecules, such as proteins and DNA, and catalyze abiotic and enzyme-like reactions, providing a complex and diverse environment for nurturing microorganisms. Many bacteria and gene fragments used in the biotech, medical, and food processing industries come from microorganisms in the soil. The soil is nature's gene bank and mankind's greatest treasure chest. Soil food webs play an important role in many types of land ecosystems. The structure, diversity, and population fluctuations of different food webs all have an impact on the cycling, immobilization, and supplying of nutrients in the ecosystem, and aggregation stabilization, water permeability, and retention of the soil. The ecosystem is also affected by the ability of soil to control soil-borne diseases, transform matter, and break down toxins. Nitrogen fixers, phosphate solubilizers, and mycorrhizas in the soil can help plants absorb nutrients in the air and ground. As such, the soil plays the role of nutrient provider to the rangelands and forests, supporting the development of the ecosystem. In the cycle of carbon, nitrogen, sulfur, phosphorus, and other elements, the soil serves to link inorganic compounds such as nitrogen, carbon dioxide, and sulfur dioxide in the atmosphere, and organic compounds such as amino acids, proteins, glucose, and other elements, which are vitally needed to support animal and plant life. Soil is the place where many organisms are born, and it is also the place to which life ultimately returns. Through interaction with organisms in the ground, many types of matter, elements, and energy are able to flow and transform in the biosphere, atmosphere, and hydrosphere. Soil plays its part in the impetus of the ecosystem and the mitigating impact of human activity on nature. Water is vital to life. Like the soil, it is a precious and limited resource. Water constantly evaporates from the sea into the atmosphere and then falls as rain onto the land. It seeps into the soil, rivers, lakes, and ultimately returns back to the sea. It is from this cycle that the living things of the earth obtain the water they need. The soil plays an exceptionally important role in the hydrological cycle. The amount of water that seeps into underground stores depends on the timing and degree of rainfall, the quality of the soil, and land use. Every year, about 35% of rainfall over land flows back to the oceans. The rest replenishes the soil, sustains plant life, or becomes groundwater. Water stored underground and in the soil are the main sources of water used by mankind, providing for 50% of our needs. The subterranean repositories of groundwater are like great natural reservoirs that store water for future use. In mountainous areas, rainfall that cannot be absorbed by the soil runs off into rivers. In extreme cases, this can lead to flooding of downstream areas. Mankind hopes to reduce the occurrence of flooding, as well as to release stores of soil water in times of drought. Both of these hopes hinge on the ability of the soil to retain water. In fact, the water conservation ability in catchment areas is a product of the water retention capacity and permeability of the soil. Road pavement, buildings, and other land uses in urbanized areas increase the permeable ratio of the land, reducing water seepage and interfering with the ability of soil to absorb water. This in turn affects the replenishment ability and water quality of underground water stores. During times of heavy rain, the appearance and severity of flooding peak increases inversely to the permeability of the soil. This is why the frequency of flooding increases dramatically as an area becomes urbanized. Due to its chemical, physical, and biological qualities, soil is able to expel and absorb nutrients from surface water, especially nitrogen and phosphorus. It can also treat chemical substances and organic waste matter, as well as reduce the level of suspended sediment in the water. When underground water passes through the soil, it is purified through its interaction with matter in the soil. Impurities in the water are digested by organisms in the soil, creating the main source of clean water for human use. Alarming levels of emissions are seriously ravaging the quality of life in areas near urban centers, industrial areas, and roadways. Satellite thermal infrared images have shown that temperatures in these areas are extremely high relative to the more normal temperatures recorded over rural areas. This is because in rural areas, sufficient surface and soil water is able to evaporate through plants into the atmosphere, lowering temperatures and buffering surface climate change. The vast amounts of nitrogen oxide and carbon dioxide emissions resulting from human economic activity contribute to global warming and pose a threat to our survival. Scientists predict that every 1 degree centigrade increase in global temperature increases surface evaporation by 4 to 5%. This accelerates the aridity of the soil and increases rainfall, thereby aggravating climate change. If we don't reduce carbon dioxide emissions, global warming could render much farmland infertile. And sea levels will rise, submerging economically developed coastal areas. This catastrophic threat will affect not just one regional population, but all of mankind. The soil can store twice as much carbon as the forests and atmosphere combined. It is the world's largest carbon sink after the ocean. Proper soil management is therefore one of the most effective ways to reduce greenhouse gases. Conversely, improper soil management can accelerate the breakdown and release of soil-based carbon into the atmosphere. Through improper land use and soil management, land and water not only cease to support human life, they become a threat to human survival in the forms of mud flows, landslides, flooding, land subsidence, and other natural disasters. Soil supports the facilities of life and serves as the bedrock of civilization, as well as the future of mankind. It is the basic ingredient in bricks, tiles, and many other materials used to build homes, roads, and other structures. Within the soil lie the vestiges of our past. From these remains, we can understand changes in global environment, climate, and life over the course of millennia. The soil also records the culture and history of mankind. It is both the mother and keeper of human culture. The traces of our past may lay hidden in the soil for hundreds or thousands of years, until one day they are discovered by archaeologists and can recount their story. Our feelings for the soil vary according to the perspective from which we approach it. In the masterpiece of nature, the soil is the source of infinite beauty, deeply stirring the senses. The beautiful forms of soil structures have been the subject of artists, unfolding in a manifold banquet for the eyes. Soil assumes a diversity of hues depending on its composition, creating a rainbow of color that lies underfoot within our grasp. Man's attachment to the soil is further strengthened by the refreshing fragrance of the earth. The liberating scent of the soil can free us from the burdens of the world and return us to the original simplicity of nature. Indeed, the soil calls to us in many forms, reminding us to cherish the earth and return to nature's embrace. Soil is the product of a long period of development and accumulation. High-quality soil is difficult to create, often taking millions of years. Over the past 3 centuries or so, the human population has expanded rapidly. To meet short-term needs, people have altered the face of the land through urbanization, destruction of topsoil, and misuse of land. Such changes have hampered the proper functioning of the soil, resulting in climate change, water shortages, flooding, water pollution, reduced biodiversity, and endangerment of the global food supply. All of these trends have a far-reaching impact on the long-term survivability of the human race. In the tug-of-war between natural evolution and the development of human civilization, people have tended to focus on the achievements at hand. In doing so, we have often neglected the goal of nurturing a sustainable world of symbiosis and joint prosperity. Given our deep dependence on the soil, mankind must seriously consider ways to make the best use of limited soil resources and to develop the concept and practice of sustainable soil management. Indeed, the sustainability of the soil is vital to the very sustainability of human life.